Hello everyone, I am Dr. Vasagiri Krishnasree, working in EC department of VNR Engineering College. Today I would like to explain about tuned amplifiers in electronic circuit analysis. So the contents covered. Today I will give the definition of tuned amplifier, disadvantages, advantages and its applications, classification of tuned amplifiers, the types of couplings and the frequency response curve, how it looks like, and the types of tuned amplifier, single tuned amplifier and then double tuned amplifier, synchronous or stagger tuned amplifier, frequency response and comparison of all the tuned amplifiers. So let us take the definition of tuned amplifier. Tuned amplifiers are the circuits which selectively pick up the frequencies and it gives amplification at that particular frequency. So this is going to give us the disadvantage of getting only one frequency is amplified, whatever the applications we needed at that particular frequency of application. The resonant frequency of the tuned amplifier, which is defined as 1 by 2 pi root LC, as the components involved here are L and C. So these two are the basic components involved in the tuned amplifier, and this will replace this LC combination, which is known as a tuned circuit, which comprises of one L and one C. So this combination we call it as a tuned circuit or tank circuit, so which is the basic element of our tuned amplifiers. So it rejects all other frequencies and then the resistive load is being replaced with a inductor capacitor load, which is known as LC load, and it has the peak gain which is at a specific resonant frequency. So what are the advantages of tuned amplifiers are? It provides you high selectivity, means only one frequency at one frequency out of the spectrum it is going to be enhanced a lot, and all other spectrums, which is a crowded spectrum, from the crowded spectrum it eliminates all other frequencies, and the power loss will be very less because of the LC components or reactive components dissipate almost no ideal power. Then it provides high gain and efficiency at a particular resonant frequency, that is, it provides maximum amplifier voltage gain with minimum DC power supply requirements. And also because it provides only a very narrow bandwidth at a different frequency, so it is going to give us narrow bandwidth, and all the remaining other frequencies have been filtered out, so it provides very low noise. That's why it improves signal to noise ratio or provides excellent signal to noise ratio. And these are usually we use in the communication applications where a single frequency need to be selected and amplified, and all the frequencies normally involved as noise will be eliminated. What are the disadvantages? So because of the bulky and expensive, due to the transformers involved as a, or inductor as involved as a one of the component of the load, it gives us the bulkiness, and because the inductors are very expensive and because of all these parameters it becomes more in weight and very large in the cost. And also basic inductive and capacitive values will be very large for low frequencies, so they are entirely unsuited for audio frequency applications, that is between 20 Hz to 20 kHz. And because cascading of multiple stages like double or stagger tuned variations, so they provide for wider bandwidths, they require highly precise circuit alignment, otherwise it is not going to give us the advantages what we require. So the complex design is going to be a disadvantage of tuned amplifiers when you aim at all the remaining advantages. So there is a trade-off between bandwidth versus selectivity. Suppose if you want more bandwidth, that is selectivity will be less, Q factors, quality factors will be less. So there is a trade-off. Whether you want to have more bandwidth, then selectivity will be reduced or the sharpness will be reduced. Suppose if the less bandwidth, selectivity will be very good. So whether you have to select either of these qualities, otherwise there should be a trade-off or there should be a balance between these two. So we cannot achieve both at a time. This is the one of the disadvantage of the tuned amplifiers. Then coming to the tuned amplifiers, as the tank circuit is the load for these tuned amplifiers based on how many types of similar loads will be connected. So they are classified as single tuned amplifier, double tuned amplifier, and these two are single stage amplifiers like our normal voltage amplifiers. When these two are connected in multi-stage, so this is single stage, that is only either of one stage will be used. Then if it is being cascaded into two stages, then we call it as multi-stage amplifiers. But there is an exclusive name for this. The name are stagger tuned or synchronous tuned. These two comes under multi-stage tuned amplifiers. So as the name indicates, single tuned amplifier features a single LC tank at the output and it provides maximum gain at the resonant frequency, but it has narrow bandwidth. Similarly, in the double tuned amplifier, two inductively coupled tuned circuits will be used as a load, and this configuration will give a flatter response and higher bandwidth. Coming to the multi-stage tuned amplifiers, first one is stagger tuned amplifier. It contains multiple tuned amplifier stages where both are tuned to a slightly different frequency. Coming to the second type of multi-stage amplifier, which is known as a synchronous tuned amplifiers, both the tuned amplifier stages are being tuned to the same frequency. So it provides high gain. Because of the high gain, it provides low bandwidth. Because of the low bandwidth, it provides high selectivity. So these are the classifications of tuned amplifiers. And coming to the applications, basically tuned amplifiers are useful for communication applications and instrumentations kind of thing, and wireless communications. First application I can take it as TV and radio broadcasting. So any radio and TV will be operating and then their signals will be broadcasted into free air. While selecting, we have to select from many signals into only one signal. That signal which is need to be selected in our radio receivers or TV receivers will be tuned according to the tuned circuit. So they select that frequency from the many carrier frequencies, either in AM, FM transmitters or TV transmitters and receivers. So this tuning is required for receiving the radio and TV broadcasting. And super heterodyne receivers. There are, it is a popular receiver for using radio and TV broadcasting. It is known as super heterodyne receiver. So here the intermediate frequency amplifiers in radios or satellite transponders are used to select a particular frequency at higher frequency so that its signal to noise ratios will be improved. Even in satellite transponders, to improve the S/N ratio in superdyne receivers, then we use tuned amplifiers. Then coming to the applications in wireless communications, or in cellular networks or Wi-Fi systems or radio relay systems based on ultra-high frequencies, these tuned amplifiers are widely used. So basically all the first three things will broadly divided into a category known as communication applications, where only one frequency is selected and all other frequencies are rejected, which inclusive of noise, so it can increase the signal to noise ratio. And if you coming to the scientific instruments, so it is a instrument, scientific instruments like medical instruments or instruments used for research kind of thing, utilized very spectrum analyzers kind of thing. So narrow, extremely narrow band signal processing, that is only selecting a very narrow band signal and rejecting by all the other signal sources like noise. In instrumentation related signals, we utilize tuned amplifiers to amplify at a particular frequency and rejecting the remaining unwanted frequencies. Then oscilloscopes and video systems. This is employed as a wide band tuned amplifiers. So for video amplification and x-axis slope or scope deflection. So if you want to have a y-axis slope deflection, a particular frequency need to be selected and then that has to be deflected on y-axis to display its spectrums, either video spectrums or any spectrum analyzer spectrums. So tuned amplifier play an important role in all these applications. So the tuned amplifier classifications will be given in a systematic manner. Basic tuned amplifiers, there will be two types of loads based on the loads, whether it is a single LC tank or first of all, based on the loads, the remaining thing will be. So first, based on the signal, type of signal, whether it is smaller in amplitude, signal amplitude, we can define into 2. That is, if the signal amplitude is order of millivolts, then these are known as small signal amplifiers. It is order of volts. So these are known as large signal amplifiers, where in both these cases, load will be a tuned circuit. Then based on the load, we can classify into single tuned, that is single load, double tuned. Double load, the load almost it is containing one L and one C component. So this act as a load. Okay. But in these are the single and double tuned, and these are single stage amplifiers of small signal. And synchronous and stagger tuned, these are multi-stage amplifiers based on small signal. But in large signals, almost all these combinations are available. But small signal amplifiers are considered in our class, in our description or in our video. So before going to the working of tuned amplifiers, just I will show how the load will be. So this is the load and a tuned circuit or a tank circuit. These are the different names will be used. One LC, C can be used as a variable and L can be fixed, because variable L is a very expensive circuit and very heavy circuit. Generally, capacitor will be taken as a variable resistance to change your resonant frequency or selective frequency 1/√2π LC. Suppose if you want to use double tuning, then a tuned circuit 1, second tuned circuit 2 will be coupled like this. So there will be a coupling in between. So it can have a mutual coupling or self-coupling kind of thing, and this coupling ratio also will be varied. So two different circuits, two different tuned circuits are used together through a coupling, then we can use this as a double tuned. So this is a single tune, this is a double tune. So this should be connected at collector to form the circuit diagram. Okay, and the frequency response curve. If a signal output frequency versus gain, if you draw the plot, okay, then you can see in the double tuned circuit, for a coupling I have already told, in mutual the coupling will be decided the frequency response. If the coupling is loose, if the coupling is tight based on the value of M, then we can have the response curves like this. But in any of the cases, at a one particular frequency, you can see it has a maximum or peaked gain. So this is the first important characteristic of tuned amplifier. Even if it is a loose coupling, so at one point you can get the coupling, you can get the maximum gain. For a tight coupling, at 2 points you can get a maximum coupling. So this is going to be frequency response curve, and this differs from one variant to another variant. So let us see single tuned amplifier and its working and its frequency response. Here, if you look at all the circuit, it is a common emitter amplifier with emitter and emitter bypass capacitor and R1, R2. These are the biasing resistors and two coupling capacitors which are needed to plug the DC value. If you apply a voltage which need to be amplified, but not all the frequency components of the input signal will be amplified, but instead the frequency FR will be decided by these two components, which is selective as 1/2π LC, at that particular frequency you can get the maximum gain. So if you draw frequency versus frequency on x-axis and its gain on y-axis, then if you draw for all the frequencies, its curve will be the frequency response curve. So this is the maximum gain or peak gain you are going to get. So to measure the bandwidth, you have to draw a minus 3 dB line, and from where, if it is expressed in decibels, otherwise 0.70 times the maximum gain, then where it inserts this frequency response curve, if you project on the x-axis, then you can get the two frequency signals F1, F2 or FL or FH. The difference between these two will be the bandwidth. Then from the bandwidth, you can select the quality factor, which is known as center frequency divided by bandwidth. If bandwidth is less, Q is more. So that's why a single tuned amplifier, you are going to get a bandwidth like this, but a bandwidth also will be very small. That is, quality factors will be very heavy. So it provides less bandwidth. So bandwidth is less and quality factors will be more. But if you want to have more bandwidth, more spectrum has to be allowed, then single tuned amplifiers are not able to provide you more bandwidth. Then we have to go for, so what is the operation in one line? I can say if an input signal is applied, it is applied at the base, but the base current will be amplified at collector current as beta times IB, but not all the frequencies it will work. It is only at one particular frequency it provides the maximum gain. So instead of RL here or instead of RC, it is replacing with a one single LC tank circuit. Coming to the double tuned amplifier. So single tuned amplifier maybe, so this is a double tuned amplifier. So double tuned amplifier, which is taking as I have shown, the tank with a double tuning with a coupling. Okay, so this coupling factor will have two types. One is loosely coupled, another is tight coupling, based on the coupling between the two inductors. And here C1, C2 are taken as variable, and all the remaining circuit, it is CE with a combination of two tank circuits as load. So this frequency FR will be at two different frequencies. It is having two peak values. So at F1 and F2, F1 is decided by this first tuned circuit. Second one is decided by the second tuned circuit. But if you want to have the bandwidth, okay, so you have to draw a minus 3 dB line or voltage gain divided by AV by root 2 times any line. Then from here you have to so actually these are the two different positions, FR1 and FR2. Two peaks will be coming. But if you take the overall frequency response, because it is producing two peaks at two different resonant frequencies of tuned circuit 1 and tuned circuit 2, but overall bandwidth, if you measure, it is going to be very large bandwidth. So in this case, bandwidth is going to be increased. Still, you want to vary the bandwidth, the coupling will be used accordingly. If you want to get a low bandwidth comparatively, then loosely coupled will be used. More bandwidth, tightly coupled will be used. So overall bandwidth of this double tuned amplifier will be more than the single tuned amplifier. So this is CA amplifier with load as two tank circuits coupled with a particular type of coupling. Then coming to multi-stage amplifiers, if you see here, one single stage tuned amplifier has connected in cascade for number of times, more than one stage. Then it becomes multi-stage tuned amplifiers, but there are two different kinds. One is synchronous and stagger tuned. So the purpose of having multiple stages, so maybe one purpose is the overall gain will be increased, or overall bandwidth will be reduced, or quality factor will be either increased or decreased, kind of thing. So for getting a appropriate bandwidth or appropriate gain or appropriate selective factors, these multi-stages will be connected in this fashion, and their resonant frequencies like FR1, FR2, FR3 has to be selected according to the requirements. Suppose you can have even double tuned amplifiers in a cascade. Then it becomes synchronous or stagger tuned, double tuned amplifiers. All the individual stages will have different tuning frequencies of double tuned. Then what is the difference between these two? So the frequency response later we will compare. For a two stage I am considering synchronous tuned or stagger tuned. Suppose if you take the synchronous tuned, all are synchronously. Synchronous means similarly. That is, if all frequencies FR1 is equal to FR2 is equal to FR3, then this is the case we call it as synchronous. Then what is the advantage of this one? Okay, say if all the frequencies are same, okay, all the three stages or multi-stages have tuned to the same frequency, they look like similar stages. The overall gain for this case will be, so I'm writing overall the case will be individual gains of first stage A1, second stage A2, third stage A3. So all gains will get multiplied. That is, overall gain will be much higher than individual gains, either A1 or A2 or A3. So for any given amplifier, the amplitude voltage gain into bandwidth multiplication will be constant. Suppose if the voltage gain is increased, to maintain a constant K, bandwidth has to be reduced. Then quality factors will be improved. So for a given quality factor improvement, these stages have to be connected in synchronous mode, so that you can get more gain, more quality factors, but less bandwidth. So the same thing you can observe over here. Two stage stagger tuned amplifier, Q is 8. For some values it is taken. Okay. For two stage synchronous amplifiers is the blue line. Bandwidth will be less. Stagger tuned bandwidth will be more. So why the stagger tuned bandwidth will be more? For in the same circuit, let us take they are connected in the stagger tuned. So in the stagger tuned means all the resonant frequencies are different. That is, FR1 is not equal to FR2 is not equal to FR3. So gain cannot be increased in the case. So gain cannot get multiplied because they are having different frequencies. So we cannot assume all the gains gets multiplied. So gain will be reduced when compared to synchronous. So gain reduces means bandwidth increases and quality factor reduces. So for the other case like Q reduction, bandwidth voltage gain reduction and bandwidth increment. So another is bandwidth increment. So for all the second cases, we should go to the stagger tuned amplifiers. So finally, we can conclude that if you take this one for the synchronous tuned, this one for the stagger tuned. So both are multi-stage tuned amplifiers. So another way of taking this one, so this is the two single tuned amplifier stages. This is a stagger tuned. Stagger tuned is going to increase the bandwidth by reducing the voltage gain. So this is a comparison on the same single tuned amplifiers exclusively. So 1.0 is the maximum gain, 0.707. It is the 1 by root 2 times. Okay, and if you look at the maximum peak gain is getting half. This is getting for 1 to half, and this is from this one it is almost being doubled. The bandwidth of individual stages, the overall bandwidth will be improved a lot. So here also exclusively I can return like this overall response, okay, on a separate sheets. This is individual stages, stage 1, stage 2, this is the overall stage. And if you look at the parameter wise, what is a single tuned, double tuned or stagger tuned? So for if you take 3 dB bandwidth, single stage will not provide much bandwidth, but double tuned will provide bandwidth compared to single tuned, a very large bandwidth. Here it is stagger tuned 2 times or 3 dB bandwidth of individual stages. So it also improves, but it is exactly how much improvement is going to take place. Suppose if you add here synchronous also, one more, synchronous bandwidth will get reduced. And if you see the frequency response, okay, then frequency response will be like a single one. Here it is a broad for double tuned, okay. It's a broad, it is a single. And if you look at the 3 stages, if I use, individually you can get, if all the frequencies are same, it becomes stagger. If individual are not same, then it becomes stagger tuned. So based on this one, it is going to differ. Now it is a stagger tuned. So overall frequency response will be like this. It is still greater than your double tuned bandwidth. And the design, single tuned is easy, but double tuned, you have to adjust the coupling factor in between 2 stages of double tuned amplifier in the load stages. So based on the 2 double tuned tank circuits, the synchronization, the complex designing will be for the double tuned amplifiers, and it is for similar to single tuned amplifiers. So once you are stagger tuned, all are different frequencies, then stagger tuned will be very easy, similar to single tuned amplifier. So these are the references have been used in the preparation of this video. Thank you for listening.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.